So my reading has shown up that there are risks to shale gas exploitation. Risks to health, the environment, water, air, wildlife, domestic animals, soil and agriculture, community cohesion. There is an increase in road deaths, in worker deaths, and in worker accidents. The house prices are likely to go down, and there are very few jobs, if any, for local people in this. It's nearly all migrant workers. We could finish this whole story in about 3 minutes by just talking about climate change. Because although we are being sold this as a bridge to clean energy, it's actually a bit more difficult to think of than that. You look at a gas flame and think, that's cleaner than the coal in my fire. But when you add in the energy to get out the gas, when you add in the difficulties of cleaning up the fracking water, and when you add in the methane leaks, which are very significant. Methane is the second most prevalent greenhouse gas. Methane is between 30 and 80 times worse than CO2 for being a greenhouse gas. It depends on the timescale, 20 to 100 years. We can go into that later if you want to know more detail. It is much worse than CO2. And about 7% of the gas that they extract leaks to the atmosphere. So that is a huge burden of greenhouse gas. If they manage to get it less than 2%, then arguably it might be better than coal. But all they're going to do is delay renewables. So it is recognised around the world, and it will be recognised in Paris very soon, that shale gas fracking is not a good thing to do. If you can either want to reduce greenhouse gases, or you can want to exploit shale gas, but you cannot do both. We don't know yet enough about this industry to say whether it's safe. Every time we ask the questions and get the answers, it provokes yet more questions. There is, however, an exponential rise in the science. The number of papers is shooting up. It has been difficult to get evidence, and that's because the companies are just a little bit coy about being examined too closely. But there is upset all around the world wherever this process goes on, and many conditions follow fracking like a swarm of persistent mosquitoes. And we will talk about some of the things, some were mentioned in the film there, which just seem to go along with fracking. We may not be able to describe exactly the mechanism or measure the amounts of this, that and the other. But if it goes with fracking around the world, it probably is from fracking. However, if I go back to evidence, they've analysed the papers, and of the papers looking at the impacts of fracking, 84% have shown potential or actual harm to public health. 69% of papers have shown actual water contamination or significant risk of contamination, and 88% air contamination. And we must remember that lack of proof of harm is not the same as lack of harm. I'm going to get this wrong. Try again. Lack of proof of harm, so you can't actually prove that it's harmful, isn't the same as saying that there is no harm. And the problem comes that it's very difficult, even for the experts, to examine what's going on underground in the rocks. You can go down a coal mine and have a little look around. You can wander around a building, but you can't put the head under the rocks to see what's happening. Industry should really demonstrate that it's safe. And it's helpful that both David Cameron and John Dewar, our driller, says that the USA demonstrates a clean, safe fracking behaviour. You may wish to check that with the New York State Department Health Report, or the very useful Concerned Health Professionals of New York. It makes a great read, but don't try and read it all at once. There's 650 references, but it's essential reading for all. Or the MedAct report, which is the two directors of public health from the UK, having a chat about what's wrong with fracking and why they believe that it is an inherently dangerous process, harmful to health. As I say, it's a new industry, 10 to 15 years old. There has been bits of fracking left, right and centre, but When I talk about fracking, I mean the whole process, from shaking the ground to see what's underneath, to actually extracting the gas, to closing the well off in a process called abandonment. Now, the industry talk about a frack, which is the actual explosion underground, shattering the rocks. But I think most people refer to fracking as that whole process, and that's what I will be referring to. So I have to describe a little bit, very briefly, what is fracking. And having done the shaking of the ground to find out where the shale gas may be, you then have this package, which is the novelty, this package of activities which are all new. You can deep drill down to 10,000 feet, and then you can swing the drill very accurately and curve towards the laterals. And they may be very long, but they're most likely to be quite short because they're more economical. You can then inject a mix of what they call slick water, a mix of water, sand and chemicals to help with shattering the rocks. They have an underground armour-piercing type explosion through the steel pipe and into the rocks to start the process of creating cracks. And then they bang down the water, 6,000 psi. Your car tires are 30 psi. So very high pressure, compressors running for a while, a lot of noise and a lot of air pollution from that. So they bang down millions, they measure it in millions of gallons of water, which smashes the rocks. This opens up cracks in the rocks which are held open with the sand, and then the gas which is trapped in the rock bubbles out and comes up the pipe because the gas wants to rise up. 30% of the water that you bang down comes back. At KM8 then the gas is transferred to Napton in pipes. It goes to an aged generator, about 50% of the efficiency of a modern generator. It's turned into electricity and then put out onto the grid, which invokes a further 25% loss of energy. This water that they put down is a big issue, as it collects chemicals from 10,000 feet down. They've been trapped down there for millions of years. And when they release the gas, they release the chemicals. So you've got radioactivity, benzene, toluene, I won't test you, benzene, toluene, ethylbenzene, and xylene, called BTEX gases, which are rather unpleasant. Complex organic compounds, often fixed with bromine, and heavy metals, of which you'll probably be familiar with: mercury, lead, and arsenic. So the gas then flows up the well, but the flow reduces to about 70% of the original flow rate over a period of the first year. So either you have to refrack it to get more gas, or you have to drill another lateral, and sometimes you drill a complete well. If you have 5 wells that you start off with, you have to drill another 3 after a year to maintain your gas flow. And this is a problem. The shale gas has probably got quite a limited lifespan. So they want to sell their operation quickly to the next person who comes with wide open eyes and excitement. They are obliged, as Paul said, to maximise their gas extraction or face possible loss of their licence. So there's going to be a large number of wells, and they described a gas farm with 50 wells on it. Then there's a grid of pipes linking well pads. And we've seen what the matrix looks like, a grid on the ground of pipes and wells. And then, it's not just a question of a nice thing that they call a Christmas tree and an underground pipe, because you need compressor stations, you need gas processing plants, dehydration plants, roads, accommodation for migrant workers, and you need flaring. Now, this isn't all in the first planning application, because this is only a diddly-squat vertical well. But once things get started, there will be no stopping the expansion of the industrialisation of Rydale, as they have to put in pipes. They will put in pipes. And you can see in Australia, great big wide swathes of forest cut down, and a road in the middle, and presumably the pipes to the side. If you want, you can have a look at Google Earth and fly over Australia, America, or wherever, and look down and see what is a typical pattern. And then the lorries come, huge, and they tend to come all at once to frack or to construct. And with that comes a lot of harm. Surprisingly, 2.5 times increase in the death rates in the roads of North Dakota. Their death rate had been going down steadily, like most places in the world. And suddenly, with fracking, up it goes, 2.5 times the previous rate. And that's found elsewhere in America. Now, the water goes out of circulation when it's put down underground. It's not in that lovely up to the clouds, into the rivers and back to your tap circulation. And where does it go, you ask the industry? I don't know. Just hope it doesn't come back up again with that list of heavy metals and radioactivity and all the rest. The silica sand, that sounds harmless, doesn't it? The USA is bothered because 60% of frack field workers are overexposed to that sand, despite the fact they should all be wearing respirators and so on. And that causes scarring of the lungs, silicosis, progressive scarring, progressive shortness of breath. It's untreatable, makes you more likely to get TB, makes you more likely to get lung cancer. The chemicals that we fire down, we don't really know what's in the tin. Halliburton like their commercial secrets. And in Australia, America, there's absolutely no data on about 1/3 of the tins. Now, we're going to have full disclosure. Well, the Shale Gas Task Force has said the newer green chemicals, they can have non-disclosure, so long as they tell the Environment Agency what they are. But that's no good for scientists. That's no good for people wanting to monitor things. That's no good for you if you get green legs and purple spots on your nose. You want to know what's going on. What are the chemicals? Has it had an effect on me? 1/3 of fracks have cancer-inducing chemicals in. They also have neurotoxins and endocrine disruptors. Tiny amounts of small chemicals that will start to mess with your hormones, controlling your hormones, your production of thyroxine, your production of steroids, your production of sex hormones. This is very new science. We really don't know what's happening. We've no idea what happens when we mix all these things, and then when we mix it with all those shale chemicals, under high pressure and temperature, great for a good chemical reaction. And then all that stuff comes back up the pipe, through your aquifer, or through your groundwater. Now, 6% of pipes, as soon as they've been made, 6% of wells have integrity issues. That means they have potential leaks. 50% will have these problems by 15 years, and probably by all will leak in time, which is why we must monitor these wells forever. And they leak methane. Methane, the greenhouse gas. Methane may just be a marker for other things that are coming out of the pipe, out of the deep shale. Because what you've done, by putting that pipe down, you've created a pathway from the deep shale to the surface. And if you didn't start with a problem, when you have a seismic event, when you have a little quake, you can crack the pipe or crack the cement, as they did in Blackpool. How do you clean an aquifer? If anybody can tell me, please let me know, because my understanding is that there's no way to clean an aquifer. There's no way actually to clean that water, even when it's in their production site. And they say they're going to clean it and reuse it, but it has to remain non-hazardous. We know that re-injection wells cause quakes. They're not allowed by EU rules. That's where you just take the water and bang it back down a pipe again, very deep. That is what they do in America because it's cheaper and easier, and they don't need to transport it. It's not allowed here, but they've just given permission for injection wells at Everston Moor and in Pickering, but not for fracking, probably, yet. So we know that humans are frail. We know that spills happen, we know that accidents happen, and sometimes the pressures in the wells get out of hand and you get blowouts. These are all disasters which are really not looked at in the mix of predicting, is fracking safe, from the point of view of the industry, because they tend to be very careful and very hopeful, and they do very good engineering. But we've seen a fantastically thick report from California which says that basically you cannot get mitigation. In other words, you can't reduce the risk of this stuff happening, you can't reduce it actually happening, to less than unavoidable and significant. So you can't make the bad stuff go away. It would be nice, but we can't.